This is going to be an explanation of the objective question 4 in Jacob's chapter 6, the learning curves. We're going to show how to use the tables that are in the book there, and they each represent something different. And we'll talk about that, and we'll also talk about the exponential equation, which is sometimes referred to as Wright's equation, the learning curve from Wright's equation, which has been around for about 80 years. What we are looking at is a table that we've recorded of the first 10 units we've produced. So by way of the question, you've just completed a pilot run of 10 units of a major product and found the processing time for each unit was as follows. So we've recorded this, and we'll notice that from the first to the second, we dropped by about 30% of the time. Just to take a quick reading of what kind of numbers we're working with, very roughly, it looks like we went from 970 to 640. We're down to 2/3. We've dropped by about a third the time. We dropped off about a third of the time just going from 1 to 2. So we should be thinking in terms of a learning rate of about 70%, because if we've removed 30% of the time, that defines the learning rate. That means that we're at a 70% learning rate. So these are the numbers we'll use. And the first part of the question refers to, according to the pilot run, what would you estimate the learning rate to be? In the series from 1 to 10 of the units that we built, there are a couple of pairings of the units that represent doubling of the output, or doubling the experience we get. And by what we see here, we've doubled, for instance, from the first unit to the second unit, you've doubled the number of units. That's the relationship that we're seeking. Over that relationship is where we'll see the manifestation of a learning rate. Every time output doubles, we can take a reading and see if we're still achieving the constant learning rate, or an approximately constant learning rate. So from 1 to 2, we'll calculate what the learning rate was over that span. We can look from 2 to 4. That's also a ratio of 2, a multiplication of twice the number of units. And if we multiply again by 2, we get 8. And there's a couple other relationships in here to keep your eye on, because we have a couple other counts or unit productions that represent a function of 2 or factor of 2. Going from 3 units to the 6th unit is a factor of 2, as well as going from the 5th unit to the 10th unit. In total, we could actually make 5 calculations with just these 10 numbers to get some kind of understanding about what we're looking at as a learning rate. So we're going to flip over to Excel here, where I punch some of these numbers in. Come over to Excel, you can see that we've got the unit number here. I put a column in here with the numbers. This exactly matches the problem we're trying to solve. And I've done 3 calculations to figure out what the learning rate is. So what we ended up with is the ratio of the first unit to the second unit, the time that it takes to produce the second unit. We look at the learning rate between 1 and 2, and that learning rate is the time it took for the second divided by the time it took for the first. We're looking at what the reduction in time was, and it took about 66% of the time for the second unit as the first unit. That's fairly aggressive, fairly steep. There was a lot of learning done there between the first and second. We were able to remove quite a bit of time, and that's a fairly steep learning curve. On average, is anything faster than 70% learning rate is pretty fast. We calculate, again, we use 2 of the indexes here. From 2 to 4, we calculate what the learning rate is again. We divide 640 by 380, and that is different than the first number that we calculated. So we're seeing like approximations of real-world data. This is not form-fit to a smooth line. This is representing some variability or variance as we're going forward in the production process. So the second ratio that we get is approximately 59%. And you can see up here the equations that I'm using to calculate that. So as we discussed, the second calculation will be from the second unit to the 4th. We appreciated about a 60% learning rate. Something to know about that, or notice about that, is that our learning even increased. Is that we, over the second to the 4th, we've actually removed 40% of the time that it took from the first. Okay, so our learning rate is actually increasing. As the learning rate goes down, that means that we're learning faster. As time goes on, we actually accelerated our learning, if you want to think of it that way. And the other calculation that we'll do for learning rate is from the 4th unit to the 8th unit, and you can see how we calculated that. That would be C12, which is 207 for the 8th unit, divided by C8 for the 4th unit. There's C8. We look at the cell, and that is calculated out to be even faster learning. So we have like an accelerating learning curve as the more we do these things, and that came out to about 54%. So for the purposes of answering the question, we'll take an average of these. Let's try to smooth that a little bit. We'll take an average of what the learning curve is. And what I did was just punch in the average for these three calculations that we did. There's the average of the three cells that we just calculated, and that comes out to approximately 60%. If we round that up, it'll be 60%. Okay? So we have established the answer to the first part of the problem, which was find out what the learning rate would be. We took these numbers to calculate that. You could go forward by just doing one calculation, but your numbers will differ as we go through this further. As the following parts of the problems will end up with a different answer if you didn't do an average there. You might have just used from 1 to 2, from 2 to 4, or from 4 to 8. Okay. Part B is based on A. How much time would it take for the next 190 units, assuming no loss of learning? So to be clear on this, they're making sure that you're looking in the right part of the graph by mixing and matching numbers that can be distracting. We're talking about 190 units for 4B. In the problem here, we can see that the 9th and the 10th unit took 190 hours. It's the same number, but we're talking about two different things. We're looking at the index here for the 190th or the 200th or the 1000th unit that we built, and how much time it actually took to build that. That's the 190 from down in the question would be your unit, which unit you're building. And I think they're just trying to test us and make sure we're not distracted by the fact that the 190 appears a couple times in our data set. These are two different 190s. Just keep it clear. We're talking about two different things. Don't get distracted on that. So the graphs I've done screenshots of the book that I have online access to, and they showed, here's exhibit 6.2 in chapter 6 of Jacob's operations management book. And this is some of the discussion. This is kind of the dialogue that you'd have around producing these units. For the purposes of this chart, you'll notice that the unit numbers are these carefully selected multiples of 2. So the first unit, the second unit, the 4th unit, the 8th unit, and that helps. In nature, we've observed that it takes a doubling of the number of units to appreciate the value of the learning curve. The learning curve occurs over a doubling of the units. Keep that in mind. That's why we're only looking at certain samples here. We're looking at the 1st and the 2nd and the 4th and the 8th because the math works out on a doubling of the number of units. That's how the math is set up here. So in this chart, we're taking a look at another example where we have an 80% learning curve here, and we have the first unit taking 100,000 hours. This might have been about an airplane, I believe. So we're talking about an airplane here. So it takes 100,000 hours to build the first airplane. The second airplane is 80,000 hours. And that's where we can see the 80% learning curve here. So we are either given the data and we calculate the learning curve, or they're giving us the learning curve and we can forecast every doubling of the units how long it's going to take. Okay? So in this case, with an 80% learning curve, it went from 100,000 to 80,000. By the 4th unit, you multiply by 80% again. 0.8 times 80 is 64,000. Multiply that by 0.8, and you will get 51,200 when we get to the 8th unit. And so you can see the relationship between the unit and how long it's going to take. So this would be 32,768 hours for the 32nd airplane we built. That's how long it would take. By the time we get to 32 airplanes, we've come down from 100,000 to a third of that. We've chopped out 2/3 of the time it took our first airplane. When we get to the 32nd, we're only down to 32,000, a third of the original number. The second column is a relationship we need to keep in mind. There are tables coming up, we can see them coming up over here, we'll explain. The cumulative direct labor hours is just the amount of time it took to get through the first 8. So when we look over here, we can see it took 100,000 hours for the first unit. It took 80,000 for the second. So cumulatively, you add the 100 for the first, the 80 for the second, and it took us a total of 180,000 hours to get through the second airplane build. Then we come down to the fourth, and we see some numbers that looks like we're going to have to go to tables coming up in order to fill this in. Let's take a look at the fourth column, and that is your cumulative average direct labor hours. And this is an average of all the time it's taken to do each of the previous units. You're keeping a running average. As you do your second and your third and your fourth, you're accumulating data and you're calculating an average as you go along. So your average should be coming down as well as your absolute time it takes for each unit. Now these tables are fairly straightforward when you use an index of 1 and 2 and 4 and 8. But in the real world, we need to know the 3s and the 5, 6, 7s that go between the 4 and 8 here, the 9, 10, 11, 12, 13, 14, 15. You know, this is not as handy because we are only looking at selections in a table that represent 2x of the previous production. So that's not that useful. You can use this. It's slightly helpful if you're only planning on building 16 or 32 exactly. You'd be able to use your table this way. So we'll take a look at the tables now. So let's go over the tables they give us. Exhibit 6.4, this table. And this shows as a factor of the first unit how much time it's going to take to do the second and the third. So these were calculated for us. Now our indexes are linear, 1 and 2 and 3 and 4. We don't have gaps between the units. We can actually look for the fifth unit. Took about 30% of the first unit when we're in this column, which is the 60% learning curve. So you look for where your learning curve is, and in our case, we're looking for 80. The sample problem we just came from, they talked about 80, and we can recognize some numbers that the second unit would take 0.8 times the hours of the first. If we jump down to the line for the fourth, that's again, we have an 80% learning curve, and we come out to 0.8 times 0.8 is 0.64 here. And if we look for our familiar indexes, you're going to see familiar numbers as we come down, as we double each amount of units. But you'll notice there's these other numbers that appear between the factors of 2 unit production. Okay, so let's look at our other table here. So this table, before we leave it, shows as a percentage of the original how much time it's going to take to, say, do the 12th unit. And if you want to know how much time it took to do all of the first 12, you can add all of these together. You can actually use a function in order to add the time for the first and the time for the second and the time for the third. And if you add all these numbers up, that's the table we're going to right here. And so to build our first 10 units, it's a problem that we're going to be working on here. This table is different. It shows the total amount of time it takes to build 10 units, as opposed to the previous table over here, which showed you the amount of time for every unit that you build. It shows you as a function of the first, it shows you how much time it took to make that unit. Okay, so all we did was add them up over here. So this number 3.813 is just all the times of 1 plus 0.6 plus all the way down through here. If you add these 10 numbers together, you're going to get 3.813 if your learning rate is 60%. Okay. Which, when we do our average, going back to our problem over here, when we did our average, we'll even add in a rounding function on this just for the fun of it. Let's do a round on here to 0 places. Use 2. We're going to format this, okay? So we need 2 places, 0.6, and we'll even format that cell to put it into percent, and this is where we'll make it 0. Okay, so that's 60%. We did a round on it, and we're representing it as a percent now. Okay, so our learning curve for the homework problem is 60%. Coming back to the problem over here. Okay, so based on A, how much time would it take for the next 190 units, assuming no loss of learning? How do we do that? Well, we could add all these numbers up, and we can see how much time it took to make the first 10. And what we can do is we can add this up, but remember we're kind of doing a smoothing function. So although we have real world, presumably real world numbers here, if we do a summation on those, that's not the direction we really want to go, but I'm going to put that in here anyway. So it's telling us, if we use the real world data, it's 3,787 hours to build the first 10. Took the first plus the second plus the third, etc., and that's the amount of hours that these numbers add up to, is 3,787. But what we're going to show is how to use the tables, because now we want to start doing some forecasting. We're going to use this average learning rate that we have over the span of the first 10, the 60%. So going back to the tables, our question, let's remember the question first. Okay, so the question is, based on A, we've got a learning rate of 60. How much time would it take for the next 190 units? Well, we've taken a look at the individual time it takes for each unit, but we also have the table that shows the cumulative time. And so what they're talking about is we built 10 and we sold them. We took data and we understood how long it took us to get through the first 10, and we still have a continuing learning curve coming up. But the question is, how much time does it take to do the next 190? Well, I'm going to shift over to the book at this point because I didn't copy the entire table out. So the entire table now, when we get here, this table is the larger table that I took a screenshot from earlier. That's what's in the PowerPoint. And this is the first table, Exhibit 6.4, and it shows for each unit how much time it took relative to the first one. It's just relative. Just whatever the time it took for the first unit, it's 0.60 for the second if you're in the 60% learning curve, which we are. There's the next table is Exhibit 6.5 in the chapter. That's 6.5, and I just copied the beginning of that out. So this gives us the relative amount of time, 3.813. Basically, you're saying to build the first 10, multiply the time it took for the first by 3.813, and you will get, along the learning curve, how much time it took for the first 10. Keep that in mind. And the question is, how long does it take to do the next 190? And we don't have that directly, but if we look at the table, we have the table down here talks about the 200th. Okay, so we have information from the 200th. And you can see lower in the table, there's larger and larger jumps. We jumped from 180 to 200. That was a jump of 20 units, and then another 50 to 250. So that's why the table isn't as useful. We're going to want to calculate this with an equation at some point, so we can interpolate between all these jumps that are in the table. So we have to figure out how long it took to do 200, and we've already calculated how long it's going to take to do 10. And we're going to subtract the first 10 from the total of 200. That is a typical way these questions are asked. So the way to calculate that, I'm going to take these numbers down here. So at 200 we have 12.09. Go back to our Excel sheet. So the time it takes for the first 200, time of 200 is equal to the time it took for the first, which is 970 hours, 12.09. That comes from the table we just looked at. In the table, I just want to show again, in the table we saw 12.09. To do the first 200 is 11,727 hours. That's what we just calculated. The time to do the first 10, which we have to subtract, so for the first 10, we come back to our table, which is exhibit 6.5, at 3.813. So this is going to equal 970 times 3.813. That's the number out of the table. So we're saying that the first 10 took a total of 3,698 hours. That's about 3,700 if you think about it. So that's how we're going to think about that. What we need to do is subtract the first 10 from the first 200 to get the next 190 the way that the problem reads. So to get that answer, we're just going to take the total minus the first 10. So the next 190 units after the 10 took 8,000 hours. A little bit over, it's 8,000 hours. And the thing to look about, take a look at the numbers. The first 10 took 3,700 hours. The next 190 took only a little over twice that. The amount of learning that goes on at 60% is very aggressive. 60% is very unnatural. That's a very steep learning curve. And it's, as you can see from the tables, it's the fastest learning curve that they put on the tables. So our solution here would be time of, really what we're saying is the last 190 of 200. That's how we solve that problem. It's a subtraction problem. So you really calculate twice, and you subtract out the beginning run, the start run, to figure out how long it took to do the last 190. I wanted to show that for purposes of a quiz on Friday, so you can understand this. Redo the homeworks. Make sure you got the homeworks down. Send me questions by email if you need to, if you can't get through them. Reread the homework, redo the homework. Make sure you understand the examples and the homework, how to come to the answers. I guess before signing off here, I just want to finish. There is one more part to the problem. And let's go back to the original question. How much time would it take to make the 1,000th unit? Remember, we have two kinds of tables here. One shows how much time it takes for any given unit, and one shows the accumulated time, how much it takes to get all the way through that unit. The total time from the first all the way through that unit. Remember, that's what the two tables are. Convince yourself of that. Go to the tables, the two tables we're using here in the chapter, and understand why they're different. Because when they ask us this question here about what about the 1,000th unit here, that's what it takes to do a little circle here in PowerPoint. That's a few steps to take. We're talking about just the 1,000th unit. Well, the first graph we had showed, or first chart rather, showed us relative to the first how much time it took. So I have to go to the other table. We only go up to 30. I only took a screenshot of the first 30. We're going to go back over to our table. And you can see we're on exhibit 6.5, not 6.4. So we're going to go up. I'm going to go up here. And we're going to pull out the number for the 1,000th unit. And what we read here is, at a 60% learning curve, the 1,000th unit took 0.6%. That's 0.6% the time it took for the first unit. So look at the numbers are still, even after 1,000, there's significant drops here. This hasn't flattened out. Even after 1,000, there's still learning going on. And it only takes 0.6% at the 1,000th unit of what it took to begin with. So how do we solve for that? Let's go back over to Excel. And so the 1,000th unit, 1,000th unit equals 970 hours for the first. That was it's always our reference point, is how it's relative to how long it took the first, times .0062. And whereas the first unit took 970 hours, after 1,000 units, it only takes 6 hours. That's an incredible drop, if I say. I think you'd probably agree with that. And that's how you solve using the tables. So we used one table for part B. This was actually question 4, part B. And this was 4.C. And that's an explanation that we tried to get through today in class. Hopefully going back through this, you'll understand it a little bit more. It should be clearer. And we'll take it on Friday for a quiz. Shoot me questions. If they're of general nature, I'll respond to everybody. Or if they're specific, I'll just respond to you. And thank you very much. I hope you enjoyed that. And it's helpful for Friday. Thank you.